Alright guys, here we go. Week 2, lesson 2. We're still on circles. We're just going to look at them a little more in depth, look at a couple special cases, and then throw in a new example where we look at a specific point in relationship to the circle. But um, if you look at the 3 examples we have here, the first one we're going to graph the circle, the second one we will write the equation for the circle, and the last one we're going to determine something about a coordinate point in relationship to the circle. The first 2 examples we went over in our last video, so hopefully you feel comfortable with it. I just chose these because it is a very unique situation with what we've been given. So again, you look at this equation, x plus 4 squared plus y squared equals 9, and it tells us everything. It tells us the center, and it tells us the radius. Now again, the center is given to us from this x plus 4 squared and the y squared. If you're having issues, again, because it's just a y squared, you can think of it as x plus 4 squared plus y plus 0 squared equals 9. If that helps you, think of it as a 0, because then once you see that, hopefully something clicks, right? It's, oh, that plus 4 means left 4, or the opposite, which would be negative 4 for your x, and for your y, since it's a plus 0, our y value is just 0, telling us that our center is negative 4, 0. So we can go ahead and start graphing that, right? We can just drop down here. Again, let me throw my coordinate grid here. Negative 4, 0 is left 1, 2, 3, 4. Up or down 0, right there is the center of your circle. After that, again, looking at the radius is the same way, right? Just like we did for the last section. You look at that 9, it tells you everything. That 9, again, we can think of it as 3 squared, telling us the radius is 3. Or, a little bit easier, you can just take the square root of 9, it is 3, telling us that our radius has to be 3. And from that, we can graph our circle, right? We just go from the center, we're going to go right 1, 2, 3. We're going to go up 1, 2, 3 from the center, left 3, 1, 2, 3 from the center, and then down 3 from the center. Again, make sure you're using something to make your graphs a little more accurate. I'm kind of just doing them by hand here. That's what we ended up with. Pretty good circle actually in the end of it, but center is negative 4, 0, radius is 3. Right? That's graphing a circle. Now the second thing we talked about in our last section, or last session, was how to write the equation. Again, we can kind of go backwards here, right? We look at the center, and we look at the radius. Now again, I chose this because it's a little bit different. You look at the center, our x is 0, saying we're going, let's say, right 0. Right, that minus 2 is telling us to go down 2. So if we add that into our equation, again, it's x plus something squared, y plus or minus something squared, right? Since we're going right 0, we can just say x plus 0. Or if you really want, you could say x minus 0, and it makes no difference because it's 0, right? That's telling us to go left or right 0. The down 2, again, make sure you're thinking opposite here. Let me say think opposite. Instead of saying y minus 2, which would tell us to go up 2, we put y plus 2. It's the opposite, telling us that means down 2 in this equation. So we've successfully added the center into the equation. The last thing, and the other reason I chose this example, is because our radius is kind of funky, right? It's 2 root 3. But again, if we're just following our standard protocol, we go equals 2 root 3. But again, we don't just leave it like that. We follow that pattern of the squareds. It's 2 root 3 squared. Right, now that's the most basic way to represent that equation. We can, of course, make it look a little bit nicer. First, x minus 0 squared plus y plus 2 squared equals, what we can do is actually multiply out this 2 root 3 squared right here. What we're going to do is we're going to take that exponent of 2 and just give it to both pieces, right? So we're going 2 squared, and we're going to do the square root of 3 squared. Now this is the longhand way of doing it. 2 squared is 4. The square root of 3 squared, right? We're just doing square root of 3 times the square root of 3, which is 9. And what we do know now is that the square root of 9 is 3. That 4 and 3 tells us this is going to be 43. That is not right. That's a joke. It's a poor joke, but it's my joke. We're actually going to do 4 times 3, which gives us 12. That's what we put ourselves equal to. So you need to multiply out that 2 root 3 squared. The easiest way is you square the number on the outside, you get 4. And then really, that squared, let me pull a color here, that squared and the square root end up just canceling out with each other, leaving you with the 3. 4 times 3 gives us 12. That is one way to represent your equation right there. A second way, you don't even have to write the x minus 0 squared. We can just write x squared plus y plus 2 squared equals 12. Just like this example over here left it as y squared. So both of those are kind of unique in the way they're represented. The last thing we're going to look at here is if we're giving the equation of a circle, like we are right here, and it's asking us, is the point 2, 3 inside, outside, or on the circle, right? The way to do this is first you can graph it, but keep in mind you might end up with a graph that looks a little funky and not the most accurate, so it's probably not the best idea. You can graph it and check it like that, but the way that I need you to do it is we're going to use this point 2, 3 to figure out exactly if it's inside, outside, or on the circle. So I'm going to take that point, write it down here real quick. What we can do with that point 2, 3 is plug it in for x and y. Right, the point 2, 3 consists of an x value and a y value. So we're going to take that and substitute it in to the equation, right? X for x, y for y, and hopefully it tells us something. So I'm going to drop down and do that. So we have, let me go in black, 2 minus 1 squared, because we plugged in 2 for x, plus 3 plus 2 squared, because we plugged in 3 for y, equals, that stays 25. Now what we end up doing is simplifying on the left-hand side. 2 minus 1 is 1. 1 squared is 1, plus 3 plus 2 is 5. 5 squared is 25. Notice how they're not the same. 25 plus 1 is 26. So we end up with 26 is greater than 25. Now what does that tell us? Right, now keep in mind, again, that 25 here on the end is telling us the radius, right? In the end, it's telling us the radius, how far out to go for the circle, right? Here the radius was 3. That told us how far out the circle was. So if this number, 26, is greater than the radius, then that's telling us that we are outside the circle. If you're greater than the radius, you're farther away from the circle, right? If you're less than the radius, you're inside. If you're equal to the radius, you're on the circle. So what we're going to say is, since 26 is greater than 25, oops, oh, come on, stick with me, I'm going to say, let's just say greater than the radius. So the point we plugged in was 2, 3 is outside the circle. And I do want you to put some sort of explanation there, right? Keep in mind the other two cases are, let's say we ended up here and we got, instead of 26, we got 24 equals 25. Now we are, lessen the radius, thus putting us, oh, come on, inside. And the last case, let me put a little box so you can see that. If we ended up with something like 25, come on, 25 equals 25. Now, since they are exactly the same, that means it would be on the circle. So those are the different cases while you're checking those coordinate points there. But again, that's us going into a little more depth into this idea of circles, right? We looked at a couple special cases. We looked at when we have a unique radius like 2 root 3. You just follow that pattern, and we were able to determine the relationship of a point in relations to a circle. Again, if you have any questions, feel free to reach out. I'm available. I'll try to be available as much as I can. Have a good day.